Hello everyone, welcome back to the Techers. My name is Surmeet, and in today's video I'm going to explain some details about MOSFETs working. How does MOSFET work? So I was just looking through my other videos. The highest views I've gotten with the resistor video, that how to choose the size of the resistor and how to check, so which makes me wonder there are a lot of people who wants to clear the basics on a very simple level. So I am going to share how the MOSFET's working, because that was also one of the topics that when I was studying a lot of people were struggling. So was I, until I clicked one time. All right, so there was a time when it just clicked and everything become really simple and clear how to actually basically use MOSFETs and BJTs, which is bipolar junction transistors. Okay, so let's jump into the explanation. You can see on the screen over here there are two MOSFETs. One is a P-type, which is the label A or on the left side, and the right side is NMOS. So PMOS means P channel MOSFET, and NMOS is basically N channel MOSFET. Okay, so in very basic thing that you want to understand how they work is the source is supplied with a voltage which goes to the drain but controlled by gate. So gate is, in general, you can see there's a gate for entry and exit, and if you close the gate nobody can go through, but if you open the gate people can go through. So same happens over here as well. The source is provided with the voltage and gate controls it. This kind of application happens if you want to electronically control the voltage supply or power supply to any load, or like a motor or LED, something like that. So basically it's a electronically controlled switch. All right, now how does it work is, in N channel, if you supply a positive voltage to the gate, it allows the power from source to drain to go through. Okay, if you supply ground, or basically negative voltage or zero voltage, it will stop. And then in PMOS, which is on the left side, it's the opposite. All right, so if you supply a ground voltage, or well, zero voltage or ground or negative voltage, it will let the current through, but if you supply a positive voltage, it will stop. Okay, so that's the basic thing. That's the entire basic working and thing. All right, now next image would be how do we make the connection. So just as explained, this is an example of NMOS. So over here you can see on the top with the source there's a positive voltage, and on the gate I've still given a positive voltage just to say, oh, you know what, that's how it's going to pass the current through. And on the drain I have attached a motor to drive. So if the gate has the positive voltage, the current will, the power will flow through and it will run the motor. But if I take the voltage away or give it a ground or negative end of the battery, the voltage will not go through and the motor will stop. Okay, now now this is the how is the completed circuit, which don't go through, like there's a lot of stuff missing, resistors and capacitors are a lot of missing, but this is like basic understanding. So all the grounds have been connected together. The voltage with the gate is 5 volts, because let's say if you want to control the MOSFET using a microcontroller or something, which is any digital controller, the generalized standard voltage is 5 volts, but then which is going to the source, it's higher than 5 volts, let's say 12 volts, because some of the motors they run on 12 volts, or any other, there are some LEDs that work on 12 volts. So just an example, I'm using a 12 volt power supply on the source, and on the drain is the motor, and again the ground of the drain is all connected together just to complete a circuit. So that's how the circuit would be. So when a positive voltage is applied, and that's how it works. So these kind of scenario happens. So let's say an example, if you're running, how they can be used is, you want to control a motor based on your microcontroller, okay? But microcontroller only provides what the newer ones, they just supply 3.3 volts with what 20 to 40 milliamp of current. But the motors, they work on higher voltage, like some work on 5, some work on 12, some work on 9 volts, and some require 1 amp of current. All right, so if they require what, let's say 12 volts of voltage to actually start operating, this is how we can control it. So on the gate, so we can choose a MOSFET which has a rating of gate voltage 3 volts for it to get activated, and which has a capability to run on a 12 volt, and we can complete the circuit like this. So we can attach the gate to the microcontroller pin, we can attach the source directly to the voltage 12 volt supply, and the drain to our motor, and it will start. That's how we can control the on and off of the motor. Okay, so that's a very basic understanding. And how does the MOSFET actually make it work? All right, so now I'm gonna, yeah, I know I'm going in a bit of reverse. In classes they first show you this, or you know what, n channel doping and this, but nobody knows, yeah, why am I studying this, right? So I'll show you how it's working, what is the usage, how it works, and then basically what what happens inside the MOSFET. So just to make this video quick, I'm going to share how does basically it works. So I'm taking an example of NMOS. Okay, so when you supply, so they have in NMOS, it's a P substrate is your main body, and N type substrates are used for source and drain. Okay, so that's how your P and N junctions form up. So when you supply a positive voltage on the gate, the P substrate, the holes or protons, or we call it, actually in this case it's called holes, which are positively charged particles. Just because they both have positive voltage, they get repelled inside the P substrate. They will repel down, making a channel for electrons to flow. Okay, so source will have a positive voltage, drain will have a negative voltage. That means the electrons will be flowing from drain to source, but our conventional current will be flowing from source to drain. All right, so that's a whole different conversation, but anyways, it starts to form a channel for the electrons to flow through when the holes get repelled down. Okay, that's why it's called N channel, and the current starts to flow when gate voltage is supplied. If it's a zero voltage or a negative voltage, the holes will get pulled up and there will be no channel. It will be completely isolated. That's why there was no current flow. Okay, and in PMOS would be the reverse. Everything will be reverse. So there will be P substrates for source and drain, N substrate for your main body, and that's how it works. But yeah, the video is getting too long, so that's the basic explanation. Let me know if you still have any questions about this. I will try to make it more simpler, but yeah, that's the basic explanation of the MOSFETs. And these are very, very important because they have too many applications. They are one of the basic, not basic, one of the very important circuit elements inside chip manufacturing, like your processors, your RAMs, even the flash drives, everything, your logic gates, even your storage devices, your newer storage devices like solid state devices, everything is basically made using MOSFET circuits. They're used for storing data. Even your logic gates like AND or NOT, they're all made by them, by using a combination of these MOSFETs. Okay, and they are really important. And we can even do basic applications, like I just said, to how to if we want to uh, what do you call, operate a motor or any other heavy loads, we can use in that way also. And there are different topics which I can cover later on how these MOSFETs basically help in storing the data and reading the data inside the RAMs or other flash drives or everything. Okay, so do let me know in the comments if everything is clear for this one, or there's something still doubtful, or there are some other topics that you would like me to cover in a simpler manner. Do let me know in the comment section. All right, thank you for now. See you.